Hi guys, if I ask you guys to name two scientists that comes to your mind at first, who would it be? For most of you, it would be Sir Isaac Newton and Sir Albert Einstein. One day, these two great scientists started playing the game hide and seek. However, the seeker was Einstein. Newton just stand beside Einstein after the count of 10. Einstein shouted out, "I caught Newton," as he was just right beside Einstein. But the Newton's answer, however, was simply unbelievable. So guys, why wasn't Newton caught just staying right beside Einstein? Newton drew a small square of length 1 meter per side and he stood right inside the square. Newton's answer was, "I'm not caught, Pascal is the one who's been caught." So what's the story behind this? Newton was standing inside a square of area 1 meter. So it's simply Newton per square meter, which has the dimensions of Pascal. All this is explained through dimensional analysis. The symbolic relationship of certain physical quantities to the fundamental physical quantities is known as dimensions. It can be also represented by any physical quantity in the form of basic entities like distance, time, mass, etc. Given here are few symbols related to dimensions. The length is given in capital L, the mass in capital M, the time in capital T, the temperature in theta or capital K, the electric current in capital A or capital I. There are characteristics related to dimensions. Let us discuss about the characteristics of dimensions. Dimensions can neither be added nor subtracted. This means the same dimension is obtained when it is added or subtracted. From the examples here, we can see that the length dimension of capital L is subtracted from the length dimension of capital L. We will obtain the length dimension of capital L, not 0. This is because the dimensions can neither be added nor subtracted. It is also seen in the example here too. Dimensions can be multiplied or divided. The dimension of the physical quantities in the right hand side is always equal to the left hand side if the equation we have is correct. No dimensions for numerical constants. If a physical quantity has a dimension, it has a unit, but not vice versa. For an example, we can take angle to determine the above mentioned relationship. There are three main applications related to dimensions. Let us talk about the applications of dimensions. Finding the dimensions or units of an unknown physical quantity. Confirming the accuracy of an equation, which is the right hand side is equal to the left hand side of the equation. Deriving physics equations based on experimental data is also an application of dimensions. Finally, we will discuss about the limitations of dimensional analysis. The method is not useful to find the formula if the physical quantity has no dimensions. There may not exist a relationship even if the formula is derived using dimensional analysis. For an example, if we take F is equal to ma, we know that the acceleration a is equal to the velocity divided by time taken. Also, we know that the time is inversely proportional to the frequency, so simple t is equal to 1 over f. But we don't have dimensional analysis related to the force equation, which is equal to m times v times f, where f is the frequency. So this equation does not exist. Few other limitations of dimensional analysis are listed here. Proportionally constant cannot be found. An unknown physical quantity whose dimensions are unknown cannot be found. only applicable for relationships up to 4 physical quantities, cannot be used to derive formula involving addition and subtraction. Quantities that are interrelated must be found by other methods or limitations related to dimensional analysis. Dimensional analysis plays a key role in the equations and the physical quantities that we deal with. Hope you guys enjoyed today's video. Have a nice day.